A car is going around a turn. A car is going around a turn. This is a horizontal road. It's not banked. That's a different question altogether. It's going around a horizontal road. The radius of curvature is 38 meters. That radius of curvature, it's not a complete circle, so we don't just call it a radius. It's part of a circle. It's a turn. And so from the imaginary center of this to the car is 38. The tighter the turn, the smaller the value of r. The radius here is 38 meters. The coefficient of static friction between the tires, the bottom of the tires, the rubber tires, and the asphalt road is 0.58. This can vary depending on the conditions of the tire and the conditions of the road. The point of this question is to figure out what's the maximum speed you can go around this turn without skidding out of control, without the tires skidding. That's based on the maximum static friction and how tight the turn is. You see those yellow caution signs as you go around a tight turn. It gives you a recommended speed. They've done this basic calculation to figure that out. Here's your force diagram. The car's weight, the normal force, which is the force of the road, up on the car, and the static friction in on the tires, perpendicular to the direction of motion. That's what turns the car. So, static friction provides the centripetal force. Well, two things here. We know that centripetal force is equal to MAC, which is mv squared over r. We're looking for that maximum speed. And we also know that static friction is less than or equal to mu times the normal force. All right, so it's the static friction that provides the centripetal force. I'm going to combine these equations to figure this out. I'm going to drop this for the moment because I'm going to look for the maximum. Remember, whenever you multiply those together, you get the max. And then I'm looking for the maximum speed. So mv squared max all over r will equal, okay, that's that centripetal force is caused by the static friction. The maximum static friction is mu times normal force. The maximum static friction is mu times the normal force. Maximum static friction is mu times the normal force. That will give us the maximum speed. This is the equation for centripetal force. mv max squared all over r equals mu times the normal force. Well, what's the normal force? The normal force is equal and opposite to the weight, which is m times g. The normal force is equal and opposite to the weight, which is m times g. So I'm going to substitute in m times g for normal force. Normal force is equal and opposite to the weight. The reason why I did that is because now I have m on the left and m on the right-hand side of the equations. So I can cancel those. Now I solve for the maximum speed. Remember, this is v squared, so take the square root. Multiply both sides by r. So that's going to be mu times r times g. It's the square root of mu, which I said is 0.58, times r, which is 38, times g, which is 9.8. And that came out to be 14.7 meters per second. Just so you know, that's around 30 or so miles per hour.